Hello, everybody. How you liking Build? Everyone's really tired. Yeah. So, were there any good sessions today? Let me hear that first. None? We're going to have to talk to some people about that. So one of the things, the reason why we're here is there was a lot of talk today in the keynote about building intelligent apps, right? But as developers, every time we hear marketing speak, our bit flips and we're like, wait a minute, what does that look like for me in real life? And so that's what this panel is for. And so one of the things we're going to do is we're going to talk about intelligent apps. Well, I'm not, they are. They're going to sort of tell us what they think. And if you have any questions, feel free to raise your hand and line up over here, right? Because this is more informal kind of thing, and ask your question. I think you're okay with that, right?
Totally.
Okay, so they're okay with that. So again, the topic today is building intelligent apps, and we'll go while there's content to talk about. But if people start walking off, we'll probably just go with you, you know, to go wherever you're eating. Okay. My name is Seth Juarez. I work Channel 9. That's my job, and I was invited to be here. I'm really excited. So why don't we start by introducing ourselves, what it is that you do, and your favorite color. Let's do that. Favorite color? Okay. Go ahead.
Hi, I'm Judy Meyer. I own the Cortana Intelligence Suite partner ecosystem, and I also have a team that does training around all of our analytics portfolio. What's our favorite color?
Favorite color, or maybe if what's
I'll
your
make
spirit?
that up.
What's your spirit animal? Like that's a better.
Tiger.
Let's do a tiger. Okay,
Wow.
love it.
I have an answer for that.
Nice.
That's awesome. Hi, everyone. I'm Danielle Dean. I'm a senior data scientist lead in the Cortana Intelligence Suite that was just announced today. So my team actually works with partners and customers building out proof of concepts and pilots using the Cortana Intelligence Suite. So we actually use machine learning and data science to integrate intelligence into business scenarios, into applications today. Oh, favorite color is green.
And spirit animal.
Oh, spirit animal.
Yeah, it's a toughie.
That's a toughie.
Yeah, I'd probably be like a goat if it was me, you know, or like a donkey. Burro. With burro. We'll let you think about it.
I'll think about it.
Hi, everybody. My name is Pablo Castro. I'm a director of engineering in the data group at Microsoft. And data, can I take the color? I don't want to do the animal thing.
He's like, we need to ask him afterwards if you pull him aside, okay? Okay, favorite color.
Okay, I'm going to stay with blue.
Blue.
Closest to Azure I can come up with.
Azure blue.
Is that too cheesy?
Typical.
It's a safe color.
Typical. All
It's
right.
safe color. Okay, there you go.
You're up.
My name is John McIntyre. I work in the data group with Pablo. I'm the director of program management, and I focus a lot on non-relational data stores. So as we think about both ingesting large volumes of data for applications as well as operationalizing that data and serving that data for experiences, my favorite color is green, I think.
Okay.
Yeah.
Spirit
It's a solid-
animal.
Raccoon or alpaca?
Nice. That's pretty varied.
I don't know.
Yeah, pretty varied. Okay. So I'm going to start with the first question. I think that's probably the most important is, what is an intelligent app? I mean, before we even start thinking about how to build these, maybe we should talk about what it is. So let's start.
That's fair. Let me start. So I think the first thing to think about when thinking about intelligent apps is that they don't necessarily mean it's particularly sophisticated or uses any of the fancy stuff we're showing here, but rather these are applications that learn from past experiences, they learn from data and change their behavior in future opportunities. So every time you have an application that collects information about what happens to it, how is it used, or what happened in the past around its context, and then it uses that information to adapt its own behavior for future opportunities, interactions with customers, then the application is being intelligent in the sense that it's adapting what it does based on the experience it has had. Some of these applications can get really fancy, and they use, whenever you talk about vision or things like that, these things get sophisticated very quickly. But some of them are very simple, and yet they can already provide very interesting experiences to customers where you can surprise them, saying, hey, like you've been doing this kind of thing, I've seen you doing it a few times, so let me help you do it this time, because you already know what you're going to do. Is it this? And if it is yes, then you're done. You can go through. So that would be kind of a short form of kind of what is an intelligent app that doesn't involve fancy algorithm names or the highest tech technology that we're showing up there.
So that's like a really cool sort of but it feels like I want to. Can you give me an example of something that might be intelligent that's really dumb, but we wouldn't assume it's intelligent, but it kind of is?
Yeah.
I mean, I would say, like, if we look at the apps that we use in everyday life and things that you have a really engaging experience with, like, let's just take Netflix as an example. Netflix learns from your behavior. It'll make recommendations for you. If you look at applications, certainly like Facebook, certainly like Uber, all of these applications provide immersive experiences because of the recommendations and the feedback that they're delivering to users. And I think there's some really interesting things that we've taken, and you can see where we've had applications that have existed almost since the dawn of time, no offense to our Office team. But if we just look at Office analytics and what the Office team is now doing to harvest mailbox data, to harvest SharePoint data, and provide recommendations in context within your inbox, I think that's a great example of taking an application that may have not been thought of as intelligent, adding these feedback loops, and delivering more immersive experiences.
So a lot of times when we're looking at this, it feels like we need to use machine learning maybe for this. Do we have to? I mean, when I picture an intelligent app, I'm thinking, is it just the menu item that has the most recently used thing and it puts it at the top? Is that intelligence? Is that the beginning of an intelligent app? I don't know. What do you think?
Yeah, I think it is the beginning. So apps that can learn from data, I think the feedback loop is a great start to a definition. So taking any kind of data that is available in that app and even doing simple things like sorting. I think one of the coolest parts about intelligence apps and the Cortana Intelligence Suite that's being built out is that you don't actually need to be a machine learning or data science expert in order to actually incorporate, if you do want those fancy algorithms, into applications. Now, with machine learning algorithms being available as APIs, you can simply call out to those and really easily integrate them into the suite. So I'm a data scientist myself, and one of the things that I've loved about the Cortana Intelligence Suite is being able to turn machine learning algorithms into APIs. So besides the ones that are pre-built for you, using Azure Machine Learning as a data scientist, I can actually operationalize those as an API, and working with developers can integrate those into applications. So previously, before this being able to operationalize as APIs, you would have to do some fancy stuff, turn your R and Python into other languages in order to integrate into applications. Now, with the ease of operationalization, it's a lot easier to incorporate intelligence into apps, even if you don't have that data science background.
So,
Yeah.
yeah.
Oh, so I was just going to add to what Danielle was saying and everybody was saying, right? From a feedback loop perspective, the operationalization perspective, for me, when I think about intelligent apps, the human ability, right, being able to pull the power of human beings, where we have emotions, where we have creativity, all of these things added on top of the power of machines, where we have computational power, where we have speed, where we have the intelligence of machines, the storage, the recommendations, the pattern recognition that they can do, right? That truly, to me, when I think of intelligence, is really what brings it all together. And when I think of machine learning, I think it really helps us, enables us to pull that front and center.
So I feel like data scientists, we've kind of made this like really esoteric. Like we talk about, like the data scientist is the one that's in the closet and she makes all the money, and then they shut the door, and then things happen in there, and then you have this thing that other happens. You're like, wow, I don't know what they're doing. Are we? When you say this is accessible, can you explain, like in dev speak, what do you mean by that? How am I actually going to put this intelligence into my app? Not in the, we close the door and Sue, data scientist, is doing that crazy work, and we peons will just be out here. How can we un-peon data science work?
Yeah, I think the key is to understand what the inputs and outputs are of whatever you're trying to accomplish with data science and machine learning. And as a developer, if you can understand those inputs and outputs, you can then integrate machine learning into an application. And that's really the key interface between the developer and the data scientist. Understanding, for example, I'm going to be inputting, in the Netflix example, lots of movies, and I want to output what's the top recommendation. So if you can understand those inputs and outputs, and understand the data that's feeding into your application, that makes it a lot easier to work alongside the data scientist to operationalize what you're doing and to turn it into a pipeline.
There is also, to add to that, there is also, like in terms of, if you think about the workflow that involves kind of building out one of these kind of intelligence features in an application, there is kind of distinct steps where developers will come in. Like there is a part of the exercise where you will watch folks that have good instincts and good experience in judging the input data set, judging the options of different models. And it's kind of an unstructured data exploration exercise where you're looking at the data, you're looking at the available tools that you have, maybe look at the distribution, like how much volume you're going to get. And that is very much an iterative process where someone that has data science background is central to kind of make good initial choices. The output of that is a bunch of choices of what is the right algorithm, what is the right approach to manage this data set, and whatnot. But then at that point, we have a set of tools that'll help you go from there into an operational version of it, where you'll say, look, the model, like we made all these choices, this trains well. We have a way to retrain. We have a way to measure that what we retrained is indeed better than the previous version of the thing. And then the next step is to wire that up into the app. And that looks like a bunch of libraries and a bunch of function calls. And the weirdness, kind of no offense, the weirdness goes away. Like you no longer talk about boosted decision trees, all those things. And instead you say, look, I have a library or I have a web service, and it's trained, so there is a way to identify the trained model that you want to use. And then you call it with a bunch of input data, and the result is a prediction, which is more often than not, it's just a bunch of numbers. And then you kind of project that into the app. So very quickly you go back to kind of a well-understood land once you went through the first step. So I think the key aspect of this is to integrate the first iteration, the first part of the workflow, where the machine learning guys, they shouldn't be kind of locked in a room. You kind of should sit down together and say, let's talk about the data, let's talk about our options for algorithms, what outcomes do you expect, and then you operationalize that.
Anything to add? Because I have a question I want to follow up on that. Because it still feels, does it feel like kind of still cloudy? I mean, it does for me, right? So let's just pretend I build my point of sale application, right? We're talking about standard POS app, point of sale app, POS app, right? How do I start to look at the data that's coming into that terminal, and how do I think, okay, how can I make this intelligent? What are some things that we can do to make that data? So you know what you're getting. You're getting person X bought this at this price. What do I do with that data now? What are some questions that I can ask?
I mean, I think one of the things that you start to do is you start to look at data in flight. So you'll look at streaming data. You may look at a stream of transactions happening where you hadn't done that previously, where you're just dumping all this data, and you wanted to do fraud detection, you want to do anomaly detection, and so you might have these great libraries that our data science friends gave us, and then we take something like Stream Analytics, and we actually analyze that data, and we look for those anomalies, and then we react to them, and so you can see that as like a very tangible application of what we might do in a POS scenario.
Yeah.
Let me kind of add to that too. So I think there's the data you honed in on point of sale data that's coming in, right? There's the traditional form of data that when somebody scans the item from a point of sale system, we collect. But there's also the reason I brought that human element too, that we have all these speech APIs, right? Face recognition APIs. All of these APIs, when you start putting in other data sets, that now you can start gathering, right? What is the emotion when Judy is checking out in this line? Is she cranky? Does her voice sound, her tone of voice, does it sound happy? Does she sound sad, right? Based on all of that data input as well, how do you make this point of sale app more intelligent? I think it's another element that we've not traditionally been thinking about, but a key element that we need to start thinking about when thinking about intelligent apps.
Yeah, and I'll just add one more point there that I think it's really important to think about what you're trying to do with the application. So not just saying, I want to put in machine learning because it sounds cool and
because we'll get paid more, right?
Yeah, I mean it looks cool. Why not?
Learning, man.
Yeah.
It's going to cost $300 an hour.
So it's important not to do it just because because of that. So you want to think about what's your end goal, and that really helps drive what you're doing and how you approach the problem to begin with. That also helps you inform what data should I even collect to begin with. So maybe that point of sale application is not actually collecting the right data because you want to approach a different type of problem. So I think if you think about what you're trying to do, that informs the entire rest of the process.
So I love the way you framed it. You're in essence asking, what questions do I want answered? Mm-hmm. And then you're saying, do I have the right data?
Yep.
But then the problem becomes, we have a lot of data, how do you start working? Because I mean, we only have, I don't know, they gave me a cheap machine. I have 8 gigs of RAM. All of a sudden, we're going to sort of, you can go tell my boss, right? I'm just kidding. I don't know if it's 8 gigs. But then you start to run out of space on your machine to do the kind of things that you want to do. Because if you're selling a lot of stuff, if it's an online store, how do we start to analyze this vast amount of data? How do we help with that?
I think, so from the data collection standpoint, we have a whole bunch of tools that can help out, it'll save you from being distracted from infrastructure problems. Like usually data collection, if it is in a bunch of devices or a very distributed environment, we have things like event hubs in Azure that are great at collecting events that happen over a vast number of collection points and consolidate them in a single spot on the server side. And once they're on the server, we have services that can process that. There are things like Stream Analytics that will go through the events, and then we can land them in places where you can process later. Like we can put them in DocDB if you want to query and maintain the stuff as part of the app. We can archive it in blob storage and whatnot. If what you have is raw volume of data, then you can just, and it's produced on the cloud already, then usually the biggest challenge is not so much to move it because it's born in the cloud, so to speak, so you have it there. What you need to do is make sense out of it and see it that is the kind of data that helps you answer interesting questions. We were actually just talking before we started here in the panel, how even though we collect data in many interesting places, very often when you sit down to solve a problem where you go like, we could do better here, let's just use the data, it turns out that you don't have enough. So the raw volume sometimes is there, but the right data is not always there. Usually, like the first thing you need to do when you start thinking about making this app smarter is go back and think about your feedback loop and what telemetry are you missing so you can actually have the right data. Once you have a data volume problem, you're in good shape because that means you can be smarter just a little bit later once you sort that out. So we found, like, I hear this very often. We're just talking about this. It looks like Danielle sees the same thing. So this is a very common challenge out there.
Yep. And then in terms of the raw computing, I think the cloud is definitely the answer. There's things like the data science virtual machine where you can say how much RAM you want. So if you're trying to solve that 8 gigabyte problem, you just slide the lever, spin up a virtual machine.
Still doesn't help my machine.
So I think in terms of the raw compute, the cloud is perfect solution to that problem. And things like Microsoft R Server, which allows you to scale out R algorithms. Things like Azure Machine Learning, which allows you to do analytics in the cloud. So I think the cloud is really a great answer to the computing problems that arise.
And I think as we start thinking about the intelligence in developing these applications in the cloud, finding that right data, because I think you do have access to data. All of a sudden, it's not just the data that you've collected, but then it's data that you have access to that's been born in the cloud was another phrase that was used, right? So how do you add all of this data, and how do you really pull out, almost filter out the right data that's important for you to answer the question that you're asking for your app?
So I'm going to ask like a couple more questions, and then we'll start raising our hands. And I will warn you, I used to teach high school, so awkward silence is only awkward for you, FYI. So if you have a question, I want you to ask it. So the first thing is, you mentioned this term a lot, the term operationalize. And I think I kind of wanted to be cool and be like, yeah, I know what that means, right? And so I'm going to be uncool, and let's pretend I don't know what it means. What does it mean to operationalize intelligence in an application?
I would look at it I think about it in two ways. One is operationalizing the code. So there are a set of models that get built and heuristics that get built, and often these are fine in a data science environment, and I'm crunching numbers and things like that, but they need to run with low latency. They need to meet the expectations of the application, and so they need to be able to run in context. You need to be able to deploy and run them potentially at scale. Not always at scale, but potentially at scale. And then from the data standpoint, when we talk about operationalized stores, or these stores that are intended to feed applications. And so as you operationalize, typically a NoSQL store is often the output of, I've crunched a bunch of data, and I've I've cleaned that data, and now I want that to be served. Like if I'm doing recommendations for a website, if I'm doing profiles, if I'm building and maintaining these over time, I have to land these into a data store that is well suited to serve applications and can have an operational workload, a high query or read-write workload run against it. And so I don't know if others have that but that's kind of how I think about it, is like the operationalizing the code and then operationalizing the data.
So what you're saying, if I'm understanding this right, is there is a specific workflow that's going to be set up that's repeatable for ingesting data and for working with the code that works with the data.
Yeah.
Is there, when we say operationalize, does it mean something different for machine learning?
It means the deployment.
Okay.
I think deployment is probably a simpler term that we could use in taking the code that you have and actually deploying it to wherever it needs to be consumed. So rather than having an R model running on my local computer, which is not of much value, how do you actually deploy it into an application? So when we say operationalization, we mean deploying it into that end application.
Yeah, we all knew that. We just wanted to make sure that you guys knew it really well. What about you, Judy? Do you have something, when we say operationalize, what does it mean to you?
No, I think exactly what Danielle said, right? I think if you want to dumb it down, ultimately, how do you create it once and make it reusable for many? So you just kind of expose the input-output so that people can kind of write and call into it, as opposed to everybody kind of copy-pasting it, I guess.
Yep.
And then my next question, before we go to the audience here, is how do I go about, I have a question, I know how I want to make my app intelligent. What are the services that we provide that sort of enable us to do that as developers? So we'll start over here and we'll just work our way. We'll start with Judy.
What are the different services?
Yeah, what are the different services that I could have access to in order to make my application intelligent? What are we providing as a company from Microsoft
Perfect.
to help do this? Go ahead.
Yeah. So we talked about Cortana Intelligence Suite, right? Within the Cortana Intelligence Suite, there's a set of about, 12 and a half different services. I like to joke half because these are all cloud services. Every day we have a new service that we can stand up. Azure Stream Analytics, Azure Data Factory, Azure Machine Learning was mentioned, Azure Data Lake. You guys feel free to jump in to count my 12.
There's definitely a lot of different services.
There's a slew of services that we offer within that Cortana Intelligence Suite, which I would say is a very good natural starting point. If you're thinking about very common architectural patterns that people are thinking about when you're thinking about building an intelligent app, for instance, hot path analytics, where you have a bunch of data coming from your cell phone. How do you analyze this close to real time? You pull in Azure Stream Analytics, for example, plop some machine learning on top of that, have a pretty good closed loop where a lot of these insights are going to be shown up in Power BI dashboard, and there it is, right? So I think within Cortana Intelligence Suite, there's just lots of permutation combination of cloud services, which, in my opinion, offers a great starting point.
Yeah, I think that's a great point. Cortana Intelligence Suite really has a lot of different services that allow you to stitch together, to use data, because I think at the end of the day, intelligent apps is really learning from data, that feedback loop, and data is a central part. So doing things like ingesting data, so there's services for event ingestion, there's services for storing data, services for analyzing data, and then services for visualizing data. So there's a lot of different services. If you go to the Cortana Intelligence Gallery, there's actually lots of samples and templates that you can utilize. So to give you one specific example, there's a predictive maintenance for aerospace solution template available where you can actually one-click deploy and see lots of different services being used together. So data comes in through a simulator to show you an example. It ingested through Event Hubs. Stream Analytics allows you to do those SQL-like queries on real-time streaming data. Then the data goes to machine learning, an algorithm is used and visualized with Power BI. So I think there's a lot of examples out there, like Hello World kind of examples, where you can see these different cloud services in the Cortana Intelligence Suite and get an idea of how they all work together. And then for on-premise, there's also the SQL Server R services. So that's another great way to do machine learning.
It's great. I think you guys covered almost all the stuff out there. I think an interesting point about the whole stack is that you don't want to be too opinionated about this because there are so many different things you can build that think of this as good separation of concerns. We have a bunch of building blocks that help you create feedback loops. a bunch of building blocks that help you explore data and do analytics that span from service-side things like Azure ML to client-side things like running R in Visual Studio and whatnot, and then components to operationalize these. But in the end, these are building blocks that are as general as we can make them, so that when it comes time to build your app, you have the building blocks, so you don't do the infrastructure work. You can do the valuable work of picking the right components and then stitching them together. And by building them this way, it also means there are no silos. It's not like we have a bunch of tools that are machine learning only tools, and then we have Azure compute hosting or storage. These things are a continuum of capabilities. So for example, once you have a model deployed out there, you probably want to expose it to an app, maybe that runs on a phone. And most likely what you'll do is you'll have a service endpoint somewhere with your machine learning model, but then you'll use regular Azure App Service to host the backend to the phone app. And from the phone, you'll call your app service. The app service will make a call to the machine learning model and then back and back. So there is this natural set of building blocks. You just stitch them together to build an app. So the whole stack in Azure is pretty much a set of building blocks that help you build apps. And machine learning apps are one way to apply these building blocks.
Yeah, I would just add, we've talked about hot path, cold path. I don't know for this audience if that means anything, but as Pablo...
Let's pretend I don't know anything.
Okay, so,
Just real easy. Just pretend.
So as Pablo and others have talked about this feedback loop, it's interesting to start to deconstruct that feedback loop. What does it look like? What are the core capabilities? And then what services do we offer to enable that? And so that whole hot path, cold path is often described as a Lambda architecture where you have data coming in. This is this real-time data. It's flying by, and you may want to do some processing. So you have to answer, or as a developer, you're like, well, what are my choices on how do I process data in near real time? I need to ingest that data. We have event hubs for ingesting that data. You can also use Kafka. So if you want to use open source technology, you can run that on Azure. It's a good choice to do that well. I think Pablo's point, don't get too opinionated on one technology versus the other. There's lots of good choices there. And then on the cold path, think of this as I have to dump my data somewhere because I'm going to do some batch I'm going to run Hadoop jobs, or maybe someone else is going to run Hadoop jobs, and they're going to gain some insights into this data, and then we'll push that data into, your favorite term, this operational store, or we'll create operational models on the other side. And historically with these, or typically what we see with these Lambda patterns is it's a BI person or an analyst on the other side of this Lambda architecture. But with the intelligent apps, you close the loop, and the app is actually consuming either these operationalized models on the other end of this architecture, or this data that's been operationalized as part of this architecture.
And I just want to, I feel like I should add a plug here for my partner ecosystem, for all of you partners sitting out there. Cognitive APIs, right? We talked about that, I think, in lots of different sessions today. Those are a mechanism for us to kind of seed the ecosystem, if you would. We have face APIs, text APIs, speech APIs. We really are looking for a lot of you folks out there, developers out there, to be contributing and adding some of these APIs, which we can add to the toolbox, if you would, of services and APIs that people are going to be, again, we'll offer it back to the community to build on top of. So I feel like it's my obligation to add a plug for the partner ecosystem.
Of course. So here's, I know I promised, but I have one more. It feels like you mentioned so many things, like choice is good, but then there's the curse of choice as well. How do we overcome that? We're really excited. We have lots of stuffs, but then how do I go to my POS app and think, I should use that or I should use that? Is there a way, is there like some sort of ontology of how, if I need to ingest data, I need to go to this section of Azure and read this? Or if I want to do intelligence, do I go to this section of Azure and see what's there? How do we separate this out?
I think there's a couple ways that comes to my mind, at least. One of the things that Danielle mentioned, solution templates, right? So these are kind of, think of it as starter templates where we're trying to showcase some very canonical architectural patterns where we're saying, all right, well, even though Cortana Intelligence Suite offers such a suite of services, what are some of the most common? So for instance, Lambda architecture, if you're trying to solve a problem for predictive maintenance using a Lambda architecture implementation, what is the set of 3 or 4 services, right, that probably helps you optimize based on the workload, your input data that's coming in, based on the output that you're trying to generate. So I feel like that's a good starting point.
Yeah, and I'd say definitely start small. Don't feel like you need to use all the
All of
services just because they're there. And most customers are typically only using a very small number of those. So figure out what you need, and then that can drive those couple of services that you bring together. Yep.
Yeah, I would add to that. I mean, if you're using SQL Server today as your back end, SQL Server now has our support, and this is a great way to start to use some of that technology in the database you're already using.
And it's a great way to sound like a pirate.
R.
Dude, I was working towards. All right, so questions from the audience. Any questions? Yes, sir. We'll come over here.
So what are you talking about is always, there is a complementary part of that which used to happen before is called user experience studies. How would you complement or collaborate with user experience and the Cortana intelligence services that you are offering? Because user experience is, again, about feedback loops and doing that before you launch the final application or even after you launch the applications. So what are your thoughts on that?
So just to reiterate, he said that it sounds a lot like the UX stuff we used to do. There was a feedback loop with UX. Is that similar to the intelligence stuff we're doing when you're talking about feedback loops? Am I close to what you're asking? And how do you collaborate with UX on that?
I'm going to make this up. I don't know. But so one thing, like I'll observe that applications that do this well start from interesting experiences and don't quite from technology. You know, when your phone says, hey, like, I know you have a calendar item, and I know the address, and I know it's a 15-minute drive, and it's going to be 15 minutes before the hour, so you should be going. So I think those are great examples of just dream the experience first. Don't think about the app. Don't think about what you can predict or whatever. Just say, like, how can I surprise my user? Like, what is an activity that is valuable to my user that they're going to do on a regular basis that I can help them accomplish it better or faster or easierly? And then walk from there backwards. At least my experience, and now I'm thinking of myself as a consumer of these apps, not as a UX person. I'm one of these backend types that never can deal with this well. But as a consumer, those are the apps that surprise me. Yeah. When I get a pop-up in the phone with these comments, and you go like, oh, you're right. Like, this is a good point. I should go, do that or think about that. So I don't know. That has been my experience.
Yeah, I would add to that. I mean, I think asking yourself as someone who's delivering experiences, what are you making users or consumers tell you that you may already know or could infer? I'll give an example. I'm also a database backend, not a user experience person, but even things that we've done in SQL Azure today. So SQL Azure today will do advisors on index. It will tell you, you have a bad, you could benefit from having an index, a secondary index, and you have a suboptimal table structure, and it will start making recommendations. Previously, you as a DBA or the customers at DBA would have to say to you, hey, I want to optimize this application, whereas we now see every single query that's issued against that database and against that table, and we can look at that data and say, okay, there are ways that we can optimize it, there are ways that we can make that experience better, and that's at a platform level where we're using that and we're analyzing all of that data and we're having the system learn from behavior and giving that feedback back to users, developers in that case.
I think he's hitting on something really special because he's saying, I think, that as we're building this app, we can start to ask the crazy question of like, well, what if the app could do this? And any of the gaps that can't be handled by UI, maybe we can handle with intelligence. Mm-hmm. Is that a good way to start? What do you think?
I do think, at first when I heard the question, I was kind of going down the path of the user experience itself being adaptive, right? Because with this feedback loop comes the learning, and then based on that learning, how do you make, with the definition of intelligent apps, I feel like true intelligence comes in when that app itself, with the user experience, however the user is going to be interacting with that app, is going to be very adaptive based on the user preferences. And that's where Pablo was talking about some of these how do you kind of get that back from the user to refeed that? I don't really know if the question was about how do we automate that experience. I think we offer some tooling that would enable you to pull that data and manually feed that back in. But I'm not sure if the automated experience, if that's what you were going after, what tooling or what services we offer for that. At least none that comes to my mind right off the bat.
And if the question is more direct around, like, how do we deliver better experiences? How do we deliver better applications? There's a ton of signals there. There's a ton of, like, in terms of engagement and how we have cameras now so we can see how people are looking at apps and how people are engaging, what the sentiment is of the experiences that we're giving them. And so there's a ton of really cool, the Project Oxford APIs that you can use and effectively extract some of that sentiment and see how people are responding to experiences.
That is a good point. The cognitive APIs that we were talking about does do the face recognition as an example. You could do speech recognition as well based on the tone of your voice. Those could be a good starting point. Great point.
Yep.
All right, next question. Anyone have a question? Yes, sir. All right, we'll bring it over here. And speak loud and hold it close.
Yeah, this is probably a weird question, but because of the intelligent design of the applications, there's a lot of data that you're processing, right? And so there's a lot of data that you're storing as the application learns. At some point, it seems like that data will be unmanageable and you would have to do something like archive or purge. How exactly do you define what you purge out so that the application does not lose important history at the same time maintaining a healthy size database?
Did you guys hear that? So the question was, we have a lot of data. When do we start throwing out data? How do you know to make
Never.
Yeah, as a data scientist, I would say, I want that, all of it. Keep it forever.
All data has value. All data has latent value.
Yeah, if you can use the cloud to store data, storage is becoming so cheap. It's amazing how much data you do need for some of these algorithms, and you don't necessarily know all of the scenarios that you want to support in the future today. So I'd say I'd put the plug in for keep as much as you can, because that data can be very helpful in the
Are
future.
you saying that because we provide data services? Or people? Let's
There
be
may be
honest.
some bias.
No, as a
Provide
data
data
scientist, that's what
We
I'm
provide data services.
I do think it's important to think about how you're going to use data and where you want to use it. And you talked about maintaining a reasonable sized database. And there are products like Data Lake where you get very cheap storage and you can push that data to that storage, and then if you want to analyze it later, you can run jobs over it. And then there's your favorite operationalized term. Then if you actually want to operationalize that data, run it in a SQL database, run it in a NoSQL database. Then you can think about where that data lives depending on the function it's going to serve.
Yeah, and at the minimum, I would say at least keep some sort of aggregate measure. If you are going to purge data, it would be good to have it over the history. So maybe you don't need every second of experience, but you need something like the count of how many times the users click something. So at least if you really are not going to go to the cloud, if you're not going to do this, keep the data, at least do some sort of aggregate over time where you can keep that historical data.
Feels like she's saying like data is our baby, and you're trying to kill our baby, dude.
Pretty much.
Let's not go there.
It's
I thought
like
you
she's
were.
a data scientist.
All right, next question. Yes. All right, hold on. Speak. Put it.
Like without data, there's no data science.
Exactly.
Okay, so I have the opposite scenario. I don't have enough data. I have a new app, maybe a couple hundred transactions a day. What kinds of things can I do to get more data, or other tools I can use to help generate my models to, get me what I want?
Yeah, that's a really good question. It's a really tough problem, honestly. So what you can do is start off with some basic model on the data that you have, and then constantly keep retraining it over time. But it's definitely a hard problem getting decent accuracy models with few data. So I'd just say implementing some sort of pipeline where you have that retraining, the model learning over time, so you can update it and it can get smarter when more data feeds in. And then seeing if there's other data that you can leverage for that application. Maybe there's some public data source or data source from another application that you have access to. I think a lot of applications get data from other sources, so thinking about those other sources too.
And I think the whole data provider ecosystem is also booming right now, right? In the cloud, I would suggest just even exploring some of those artifacts. A lot of people are getting in the business of selling data, so that's another avenue.
Yeah, so this cold start problem it's very common. Another thing to keep in mind is the work to kind of design and train a model and the work to ship it doesn't have to come back to back. So, when you're working on the model, one of the key aspects you're going to define is a quality metric. You got to work on the quality metric. So I'm going to create a feedback loop so I can start collecting data. Then I'm going to work on models. But that doesn't mean you're going to integrate into the app because now you're net regressing the experience. So just work on the quality metric and see if you can kind of make it trend towards a point where you hit a threshold where then you're comfortable shipping it out. And while you're not there, maybe you're just training your models and remeasuring, but you're not wiring the model into the app until either you have enough data that gets you through enough of a quality metric, or sometimes you can use a knowledge transfer trick where there is a similar enough domain where you can train over there and then the transfer works. It is not always the case, but sometimes you can find domains that are similar enough. But this is we all face the same thing with both cold start and just net scarceness. Sometimes the volume is not there. We all talk about, when you go and say, well, Bing uses a lot of data. It's well, yeah, sure. I mean, they don't know what to do with it. But our regular customer in a regular setting, even if you get thousands or tens of thousands of data points a day, that may not be enough to be significant. So I think decoupling the exercise of exploring from actually shipping is a key thing that sometimes you get the ball rolling and you go okay, I'm going to just roll through the whole thing. And then I end up shipping a model that either doesn't have a quality metric or it's not even close to hitting a quality metric. So now you just made your application worse.
So how much is enough, right? How do I know, just more to get back to your question, how do I know when, okay, I got enough, I can start doing these things? How do you know?
Yeah, it's a really hard question. So I have worked with customers on trying to define this, and it's extremely hard. It really depends on the scenario. We were talking about this before. Sometimes metrics like accuracy don't even portray how well the model's doing. You need to look at things like precision and recall instead. So it's a complicated process. What it comes down to at the end of the day is what value are you getting? So in the business scenario, are you actually providing value? And if you can translate that into numbers that you can reflect in your metrics. And often what you have to do is figure out things like how much better would I have to be in order to improve that user experience or improve the value, and to kind of work backwards from the business definition back to what does the model actually have to produce.
That's awesome. All right, we'll take one more question. Any more questions out there? Okay. Hold it really close to your face.
What has been the best bang for the buck? What kind of data would give you the best outcome? Is it the performance of the applications or things like that, or is it about the actual data that you collect, like point of sale application? Is it about your transactions and stuff like that? What's the best bang for the buck?
So the question I think was what data is going to give you the best sort of bang for your buck when it comes to machine learning? Is that right? Or intelligent applications? What do you think? Really tough question.
So I don't think there is a universal answer. I think it depends a lot on what are you trying to achieve. In many cases, at least recently, it seems that when we talk to customers, this is more functional type data, not performance data, for example. But sometimes, what you're trying to learn is how to optimize a system. And now that we have all these tools, we tend to apply machine learning to all sorts of problems, including performance tuning problems. Thinking myself in the role of I run all these engineering teams that build Azure services, and we think of ourselves as an app, as an intelligent app. where we collect a lot of logs. Some of them are functional, like what do you do with this stuff, and some of them are more like technical, like what is the what is the average latency day to day, and things like that. And depending on what you want to solve, you'll track one or the other layer. Like in the performance front, maybe you'll track latency and whatnot. But thinking about the POS scenario, then you would think, well, what are interesting things? Like, what are you trying to solve? Maybe what you're trying to solve is, how productive the operator of the point of sale is. So you want to say, well, ideally, I don't want people spending time hunting for the next product that they are going to buy. So you would say, every time somebody buys this and this, then they also buy these other three things. So you can do this, this collaborative filtering type of thing. And if you're going to do that, what you want to track is who buys what. So then there you go. So your telemetry for that is who buys what. So depending on the scenario, you'll decide, in the domain of your application, what is the right metric at the appropriate level of abstraction so that you can create this loop. And so one aspect to think about this is sometimes you just log the raw data, like product ID, person ID, or something like that. But if you're going to train a model, the more context you can bring into this, the better. Folks that do this, they call this feature engineering. Like, it's like figure out, besides the base data, what do I know about this data that is not obvious in the raw data set? But if I can augment the data set with this information, then it gets more interesting. Like, for example, in the case of if you're doing recommendations, you can say, well, what season is it? Is it the end of year kind of holidays, or is it summer, or is it winter? Or maybe you can ask what time of the day is it, or is it a day or a weekend? And all these things that are not obviously related to the pairing of users to products may end up influencing your choices. So they enrich the data such that the models that you compute afterwards they end up being of better quality. They have better predictive power because they have more context to go off of.
Awesome. All right, so we're going to wrap up. I'm going to give you each sort of about a minute to just sort of wrap up sort of what we've learned, what advice you have going forward, and then we're going to end with a raucous round of applause, I think, right? So let's start over here, Judy.
All right. Well, I think to summarize for me, go explore Cortana Intelligence Suite. I do think it offers a truckload of beautiful services for you guys as a starting point if you're thinking about intelligent apps. And for me, going back to the original question that Seth brought up, what is an example of an intelligent app? I do think when we have the ability to combine the human abilities with the power of the machine, that truly, to me, makes an intelligent app. For me, when my kid can kind of walk the streets feeling safe because there's all of these predictive things that apps that we've put out there, folks like you have put out there, which makes the place a lot more secure because people who are going to be kidnapping kids are already behind bars before they could kidnap kids. That to me is a beautiful world where intelligent apps are put to good use. And I think one other example that comes to mind where medical use cases, right, with healthcare applications, those things kind of growing out where my parents can live a healthy life where just based on the tone of their voice, their speech recognition that the doctor or a nurse who's just talking on the phone is able to predict some of the symptoms, not just based on the vitals that are being collected, but all of these other elements that feed into an intelligent app. To me, that's a beautiful world. So that's my summary.
Yeah, awesome. And just to add on, I would say start with what you're trying to accomplish. What are your goals? And then work backwards to what can you utilize from things like the Cortana Intelligence Suite. There's lots of tools that enable you to do these things faster, but you don't do it just to incorporate machine learning. Start with what you're trying to accomplish with the application. Maybe you need something extremely simple. You don't need such fancy technology. And start with the business scenario and then work backwards to what tools you need.
And yeah, so to build on top of that, what I would say is start small. Not only work from your problem bag and start, like if you find yourself reading Wikipedia more than using Visual Studio, then you're pushing it too hard. And most likely there is a small solution, a small incremental step there that you can do that not only will get you going, but also lets you test the waters. Like, is this, am I improving this experience? Do users think it's better? So start small, build something, ship it, and then come back and iterate. And then, so you'll have plenty of opportunity to make things complicated. And I think we all know as developers that this code just grows over time. So that's not going to be a problem. So start small and just get something out there and start to build out the experience. Then over time, you'll have opportunity to get more sophisticated, more accurate, and just generally better at it.
All right, John.
Yeah, I would just reiterate Pablo's point is start with something really simple and start building that loop. Start collecting that data, start asking questions. And you may not build the full feedback loop to start with, but you'll start looking at data and asking questions and how you can improve the behavior and the engagement of your applications. And then that will give you a sense of how you want to close that loop for your application.
Awesome. Well, thanks so much for spending some time with us. Thanks so much for coming. Let's give him a round of applause. And we will see you bright and early tomorrow at 8:30. Take care. Have a good night.
Right.